The main problems with the construction industry in general at the moment are centred around poor information flow. So conventionally we've operated with 2D drawings. For us, working directly for manufacturing businesses, that's meant that we've worked with largely insufficient or unclear information and centred that with tight timescales for turning work around. Obviously the price sensitivity within the industry. The industry is very much driven around cost and turnaround. So for us, improving information flow and getting information flowing better through the design team is kind of paramount to improving the way the industry works. For us at the moment, working in conventional 2D drafting methods is slowing the industry down. Jobs are costing more money to deliver, and ultimately things aren't being built and designed as efficiently as they could be. So a prime example of where we struggle currently, things like helical staircases. We'll just receive a circle in plan on an architect's drawing. So that information is very vague. We don't ultimately know what the client wants. So from that point on, the fabricator has to guess what the client wants. We in turn have to guess what the client wants. And then in actually trying to achieve what the customer or the end user actually wants from the project, that's what takes the time and costs the money. So improving that information so that the information as it reaches the manufacturing businesses is actually complete and clear and concise. That's ultimately what we're aiming to achieve.
Yeah, and from the consultant's perspective, many years ago, back when I started doing engineering, we used to take a lot more responsibility on the connections as an example. We would design the connections, we'd think about buildability issues a lot more. We would have a better understanding of the fabrication process. At the moment, the way the industry is set up, a lot of the consultants then leave those sort of fundamental aspects to the contractor and the fabricator to deal with. That in turn obviously brings in other problems associated. So the young engineers of this world now are thinking slightly differently. They might be thinking about weight as a primary, as a priority rather than actually buildability. So we have examples where we deliver a steel frame building that encompasses probably about 20 different beam sizes. We're totally focused on weight as a cost rather than looking at the connection. So the connection design could actually sometimes outweigh the actual physical extra steel that you need if you rationalise some of the structure. In turn, that obviously then goes down to the supply chain, who have to assume or try and understand the design and the drawings that are being issued to them, and ultimately they can get it wrong. So traditionally we used to sit as a consultant and say 7.5% was sort of a round number that we'd add to the cost of steel. Personally, I think that number is a lot more now, because the engineer themselves don't actually think about what that cost of the connection really is. So having steel work off centre, having moment frames, whatever it might be, all this adds additional cost to the fabrication process. So I think actually as a concept we should start looking at the buildability issues rather than just the weight of steel. I mean, steel is a cost that is fairly consistent for all fabricators to supply. But you have to ask yourself the question, why are the tenders coming back so varied? In theory, they should all come back pretty similar. So if the design team took more responsibility in actually designing and coordinating those things up front, and that might mean bringing in a fabricator or a contractor early on in the design process, deliver a 3D digital model, for example, probably reduce the 2D outputs. Everything is driven from that 3D environment. The fabricators are very used to taking 3D models and using that. You can get accurate quantities, accurate design information, accurate connection design details. It can only improve ultimately what the client pays for, and I think it's the way we should be working. The big challenge for me is changing the perception of what we're trying to do, people that you're working with, the culture of how we've always done it the way we've always done it, so why change the way we work? Technically speaking, as I said earlier, we're not actually changing what people's roles are, we're trying to improve the way we collaborate and share information. It's as simple as that. We haven't invented the wheel. You know, it is what it is. All we're suggesting is, you know, we've got young people coming out of schools and universities. This is the digital age of youngsters working in Minecraft and various other iPad technologies. And they come straight into an industry that should be screaming out for young people who are going to change the way we work. Give them the tools and they'll create great things. And
while a lot of the larger companies can invest in technology and invest in new processes, there's a huge proportion of project work that gets done across the UK that's done by the SME sector, the small businesses, the small companies with 5, 10, 15 employees. This is where we've got to really change the culture and the attitude towards BIM and digital engineering, because ultimately, if we're going to change the industry, we need to change the way that we deliver the projects. For us, that means for us, instead of focusing on working as we always have done for the last 25 years, where we get commissioned to work on a project where the information's very poor, the time frame is very tight, so we're often given 8 weeks work to do in 6 and expected to turn up and help the fabricator get to site in 6 weeks' time with a finished £500,000 piece of art that needs installing in a lobby. So for us at the moment, the challenge is changing that attitude and that culture. We've got to move forward. Technology is the future. Getting young people into the industry is the future. And as Jon mentioned, we think people are critical. So we just want to work and engage with like-minded people that are happy to take the challenge on, knock down those barriers in terms of how we share information and how we work contractually, and actually start to develop and build a new way of working that's going to enable the construction industry to survive. I think for us, the opportunities around technology, there's people now likening it to the second industrial revolution. So obviously we've gone from conventional drawing boards into 2D AutoCAD, and we're now moving from 2D AutoCAD into 3D modelling. And the final process from 3D modelling is obviously building information modelling and digital engineering. So I don't think there's ever been a more exciting time to be involved in the construction industry. Unfortunately, the barriers that we've got to overcome, the fact that this technology isn't being widely utilised, the way that jobs are procured currently needs to be addressed. So at the moment, the way that projects are procured means that the steelwork fabricator or the architectural metalwork business that we currently serve has to win that package of work based on very vague or ambiguous information. If we can change the way that jobs are procured and actually start to build projects digitally before it goes out to the supply chain, that information will become more accurate, and ultimately those fabricators, those architectural metalwork businesses will be able to price more accurately and more consistently and in line with what the client actually wants.
The industry is moving to this digital revolution. 3D models are fairly standard now, so technically speaking, a 2D drawing is created from the 3D model, and that's the drawing that's being signed off to actually issue to the contractor and the fabricator price upon. It just seems totally stupid really that you have 2 deliverables, twice as much time taken up, and actually in reality we probably create too much 2D than we ever did when we traditionally worked in a 2D environment. So the concept should be actually reduce the 2D outputs, focus on the 3D model. That's ultimately the digital building that you've designed. The model itself becomes the primary contractual deliverable. You sign the model off, you utilise the geometry and all the data withheld in the model, hand that over to the contractor and the downstream sub-consultants, subcontractors, and the drawings just become a supporting piece of information to the model that you can't actually set out in the 3D world.
So for us, the natural merge into what design for structures represents is basically all of the positives that you get associated with a structural engineer in terms of the structural analysis, the structural calculations, but with the added bonus that behind that facility is also all of the manufacturing information. So what we're able to offer as a consulting engineer to clients and developers is not only all of the structural engineering aspect of the project, but also a full set of manufacturing information that they can take out to their supply chain with absolute confidence that can give them price security and an accurate package of information to be able to price and install to.
Well, for me personally, I started off life, my working career working for a family business, small consultancy, and back then the responsibility was to do everything. So we took on the connection design, we took on other aspects of the building like reinforced concrete, below ground drainage, infrastructure works. Traditionally, that was something that the engineer designed and responsible for. So we had a better understanding of a lot more aspects of buildability issues and how sites were actually, projects were actually delivered on site. moving away from that sort of smaller scale type of work, going to the large consultants, certainly around the London region on the mega projects, fantastic jobs as they were. Obviously the element of your role changed completely, so on the big projects, structural engineers generally did the structural design, the connection design was then handed over to a contractor or a fabricator, reinforced concrete was then passed on to somebody else to finalise the design. Similarly, infrastructure and civil engineering was passed over to another discipline. The aspect of risk was sort of passed away to various different teams and disciplines to take on the design and finalise it. For me, that's a frustrating thing. I think we should take more ownership of the design and the buildability aspects. So for me, I'm passionate about bringing in the contractor and the fabricators earlier on. Their knowledge is absolutely paramount to the design. You know, generally speaking, you can design whatever you like, but if you can't build it, it doesn't work, it's flawed, it's failed. And a lot of time, like I said, the information that's issued has caveats on the drawings, connections to other people's responsibility, coordination is also passed on to some other disciplines. And I feel like we should take all that early on. It might mean front-loading certain fees, it might mean the culture of people and the design changes, clients' aspects and the way they think about how we deliver a project may have to change. But the benefits can only be positive to the whole delivery of the job.
At the moment, what we've tried to do in terms of bringing D4S into the market is we've tried to look at, rather than acting like everybody else is, which is doing the bare minimum for the bare maximum, let's say, we've tried to actually pull together our resources to actually offer what we believe the market needs. And what we believe the market needs is an engineering solution and a structural design solution that encompasses other aspects like the manufacturing of steelwork in our experience. So the industry has become more and more multidisciplined over time, and so collaboration and working together and working and communicating effectively is absolutely critical to the long-term succession of the industry. For us at the moment, we've felt that the only way that we can actually ensure that collaboration between engineer and steel detailer is to actually become one. And that's ultimately what we've done with D4S. So we believe we can add huge value to clients in terms of giving them the service that they're expecting to get, but at a higher level, but also with adding in those extra levels of service that TDS can offer as a byproduct. So for us, I guess the industry, we all need to upskill. We all need to embrace technology. We all need to communicate more, and we need to knock down those barriers as to why people are reluctant to share information, so that ultimately we can build buildings better.
BIM shouldn't be seen as a problem. If any, I mean, BIM for itself is a process. Its core is collaboration. It's a tool that we can use. Technology is a tool. We haven't changed the way we work to a certain level. Engineers still do engineering, fabricators still fabricate, contractors still build. The reality here is just to break the silos down and actually come together, maybe change the time at which we are joining these disciplines and sharing information. The 3D model environment is nothing to be scared of. It should be there as a tool to help you get across to the people you're working with what your aspiration of the building is, how you've designed it. There are so many positives to using the model. It shouldn't be seen as a hindrance. We shouldn't have to keep reverting back to the way we've always done things. It's just never going to work.
Generally, manufacturing companies want to manufacture. So steel fabrication companies, architectural metalwork businesses, their business functions on the manufacturing and installation of their products. So many of those businesses see drawings as a complete necessary evil. I think from our perspective, producing digital packages of information that is manufacturing level information that you can give to the manufacturing supply chain, that is going to be a huge incentive for manufacturing businesses to work on those projects. So while we've got this risk-averse culture that ultimately says, well, not going to worry about that, let the fabricator worry about the drawings, let the fabricator worry about the design, that's an area that we want to focus on in terms of we can bring our manufacturing experience and we can bring our steel detailing experience into the engineering package to produce DFMA packages that can go straight out to the manufacturing supply chain. And what that's going to do is that's going to upskill a lot of manufacturing businesses that have got manufacturing capability and fabrication capability, but not necessary capability in digital engineering, not necessary capability in BIM, and sometimes not even capability to actually produce drawings, where a lot of manufacturing companies now don't have internal drawing offices.
BIM and digital engineering shouldn't be seen just for the mega projects, the large consultants, the large tier 1 contractors. BIM should be scalable. The whole concept should be scalable. We can do this on a garden shed, or we can do it on an airport. It doesn't matter what it is. The process and the concept about sharing and collaborating still exists on whatever the size of the job. I think there's a sort of a misinterpretation that you can only do BIM if you're one of the big players on a mega project. And obviously we see it all the time with High Speed 2 and Crossrail and the big airport projects, but it shouldn't be the case. You know, BIM shouldn't be just for those elite 5–10% companies out there that can do it. There's, as Dan says, 90% of the industry is driven by SMEs. I think personally, if you get the SMEs together and they grasp the concept and we come together as small teams, people will make the change, we will make the change, we will start delivering projects better and actually show that this isn't just for those big players who have this seamlessly bottomless pit of money. It's not the case.
The people are still viewing BIM really as a more expensive way of actually designing a project. You know, we recognise that that BIM ultimately isn't just about building the project. It's about how that project is maintained and how that project is managed. So, you know, we're focused around building a digital asset, and that digital asset is going to be just as valuable as the actual physical asset. At the moment, you know, we work on refurb projects across the country where we have to go in and we have to hand measure and hand survey things. BIM is going to prevent that in the future. You know, when we're designing buildings now, we're not just looking at how we actually build it the most cost-effective way. We're also looking at what about when that staircase balustrade needs replacing? What about that balcony infill panel? When does that, you know, what's the lifespan of these products? And how do we replace those products cost-effectively when they need replenishing? And I think, you know, until the industry wakes up and realises again that, you know, the BIM process isn't just a set of drawings to build a building. It's far more than that, and it's far greater than that, because again, you know, speaking about where we conventionally appear within the industry at the moment is working directly for a steelwork fabricator that wants the cheapest set of drawings in the quickest amount of time in order to make the steelwork. That culture isn't going to enable us to move forward with technology and with innovation. So again, taking that process to above the manufacturer, where that information is provided to them, means that jobs can be priced far more accurately. The client is going to get less variations, less design changes, less conflict. And I think that's the culture that we want to embed within the industry, and that's certainly the types of projects and the types of people that, as D4S, we want to work with.
Coming together with like-minded people, so coming together with clients, architects, building services engineers, whoever they are, if they see the opportunity, understand the opportunity, and they actually want to change the way we deliver projects, then you'll do great things. You'll come together, you'll share information, you won't view it as it's all mine. The silo mentality is broken down. We agree how we transfer data and information to each team. There's no sort of associated risk about, you know, the drawing wasn't checked properly. We don't think that way. We're all in it together to deliver this project in the best and most efficient way. So transferring a 3D model to you, taking data back from another discipline, that should be the norm. We should be just taking that information in. We shouldn't even be thinking about it's mine, you carry risk, who can I blame when it all goes wrong? That culture has to change. It's not a culture of blaming people. It's a culture of actually coming together and doing it right first time.
The information that flows through the industry improves and starts to be more transparent and starts to be more clear on what everybody needs to deliver. We're going to continue to tread water and continue to fight in a cost-effective way. I think the ultimate irony with BIM as a process is that the money that needs to be speculated at the front end of the project is absolutely dwarfed by the savings that can come out of the back end of the project. And ultimately, the person that's going to make those savings is the client. So for me, this whole process has got to be client-driven.
Consultants started many years ago to take responsibility of the buildability issues, the connections, and as as times have changed and as things develop, that sort of associated risk has got passed to other people. And what we're saying is, why is that the case? If you're doing the design early on, why aren't you thinking about how you connect the two bits of steel together, for example? Why aren't you thinking about the reinforced concrete design? Why shouldn't you be coordinating those major pieces of work early on? They all have a knock-on effect with other disciplines, other services, other bits of the building that you're putting together. So coordinate early on, iron out as much of the risk as you possibly can at that stage, deliver from design to the contractor and to the fabricators a better piece of information that they can price accurately off, and stop this concept of, if we find a problem, the client gets charged extra, the blame game starts going all the way back around the system, and we spend so much time sending RFIs, emails, picking up the phone, chasing information. Why doesn't it fit? Why didn't we look at this early on? I mean, it's common sense, really. Why wouldn't you do it? You've got a physical 3D digital engineered building from day one. Why isn't that fit for purpose, handed over and used all the way through the process of build and then handing over to facilities management? Why wouldn't you do that? It's just the most simple, common thing that you'd do.